In this problem, I am given some data in order to model a sinusoidal curve. One thing that we would recognize is that the period is 12 hours. We would also know that the high tide of 7 feet occurred at 5 a.m. and the low tide occurred at 3 feet at 11 a.m. Therefore, I have these 2 points. We will also recognize, since our period is 12 hours, that if we split our graph into the 4 equal parts to cycle the sine function, we would know that our critical points lie 3 hours away. This makes sense because I would go 3 hours to find my average value, or at 8 a.m. I would have my average value. 3 more hours would take us to 11, where I would see my low tide occurring. From the high and low, we could find the average, giving us D is equal to 5 feet. We would also know A as the amplitude, and that amplitude is the maximum deviation from the average to the high or the average to the low, giving us A is equal to 2. Therefore, we would know that A is 2 and D is equal to 5. We can find B because we know the period for a sine function is 2 pi over B, and our period is 12 hours. This would give us B is equal to 2 pi over 12, or pi over 6. Finally, we are trying to find the value of C, which we know that the opposite of C over B gives us our phase shift. For the phase shift, what we are actually asked to find is an original sine function. We know that our cycle interval starts at our average value, in this case of 0, where the function is increasing towards that maximum value. We want to find the same point on our graph. If we would use the point 8,5, we would notice that although this is an average value, the function is decreasing at that point. That way would not be our appropriate phase shift if we want A to be positive. So in order to find that appropriate value, we are going to go in the opposite direction, and we know that from this high tide that occurred at 5 a.m., with 7 feet, 3 hours prior to that, I would again been at my average value. 3 hours prior to that would give me 2 a.m. Therefore, I know at 2 a.m. my function is at the average value of a tide of 5 feet, and it's increasing through that maximum tide. Therefore, we know that our phase shift has to be equal to a +2. Now we can solve for C. We have the opposite of C over B, which is pi over 6, should equal +2. We can multiply both sides by a negative pi over 6 to solve for C. This tells us that C is equal to a negative 2 pi over 6, or negative pi over 3. Therefore, our equation is given by y is equal to 2 sine of B minus pi over 3 plus D. Another way we could have looked at the phase shift is we could have wrote this, what's in parentheses, in factored form. This would be equal to y, and y is equal to 2 sine of pi over 6 times t minus 2. We would recognize in this factored form that we see that phase shift of a +2.